We'll start it. Let's see. So in our course 171, and yeah, you got 2 announcements today. You got 2 emails from me today, both of them titled Week 6 announcement. But the first one was just what's due this week, what's due, and what's coming up. And then the most recent one is the one about the test. Everything about the test is going to be based on your work. Okay, getting the right answer online is not going to get you a whole bunch of points without some supporting work. So if you need to do something, if you need to write something down to get the right answer, write it down and show it to me. When you get done with the test, you have 24 hours to post those notes. You can actually click the course link right here in that announcement, or go to week 6 where it says submit chapter R test work. So that folder is right there as well. Okay, you have 24 hours from the time you finish. We've done a lab now, so you know what's expected in terms of submission. You know that I want 1 single PDF file. So that means 1 single PDF file, not any other kind, not any other type, and make sure that it's something that, make sure it's a PDF file that will open. Had people in other classes have missed out because they submitted files that don't open. Will you be able to write down formulas? Yes, since I don't have a camera on you, it's, if I were to say it's no notes, then all of the honest students would do it without notes, and then the dishonest students would do it with notes, and that's unfair. So yeah, you've got access to the internet, you've got access to your book, your notes, all that stuff. I would suggest, I think the test will go better for you if you write it down on 1 piece of notebook paper, front and back, or maybe just front, and then go into the test with that. Because if you go into the test thinking, oh, I can just look this up on this website, I can do this up there, you won't study. And then when that timer starts and the minutes start ticking away, people freak out. They'll spend all their time flipping through their notes and not any time doing their work. You can email a picture of the note. No, there's a link in Blackboard. There is a link. So under that weekly lessons, week 6, submit chapter R test work right there, and browse local files. That's where you'll get it. And then you'll find it on your computer. Okay. Excellent. All right. If you don't have the Cam Scanner app, or you're not comfortable downloading that to your phone, take pictures of your work, email them to yourself, paste them into a Word document, and just make the pictures the full size. Make 1 picture the size of 1 page, and then you can go file, save your Word document as a PDF. So let me show you, rather than talk about it, let me show you about it. Let's get some of my pictures. So here's a picture of our textbook. I'm going to expand it to take up the entire page, but it's just remember, I've got to be able to read this stuff. And then come down to the next page. Here's another picture that, oh, that's not, the picture is not. See, and that's the kind of stuff we want to avoid. Did it again, didn't I? Here's another image. Extend it so I can see it. And this one, I might even, flip it so that the most reading can take place, and keep doing that until you've got all your work in there. And then when you're ready, just go to File, Save As, and you can change the type right there to PDF. So now what it'll do is save, and you'll have to give it a file name, but then you can save all those images together on one document as one PDF file instead of each page being its own PDF file, because it just makes grading so much easier. And then I can go in and get in where I can even get in there and circle the stuff in a PDF where I can show you where I think it went wrong or highlight where I think some issues are. But if you send me individual images of each page that are all attached differently, it just makes a mess. So yeah, part of this one is going to be following the directions, and part of following the directions are just submit the correct type of file. All right. So everything's graded up to now. Is there a definite way to make sure the file can be open? The best way to do that is to save, once you get the file and save it, open it. If it opens in Adobe, as an Adobe PDF reader, perfect. That is all I want it to do. Andrew, only PDF files are accepted. I think I have there. If you submit a file type that does not is not PDF but does open, it costs you 10 points. If you send me a file type that does not open at all, that's a 0 for the test. Good. All right. It's the frustrating part of having being online is that it goes beyond. It's not enough to not cheat. It's to remove all doubt of cheating. So it means that online classes are tougher because we have to ask more of everybody. There is a time limit. It is time limited to 2 hours. And I think it's 20 questions. Yeah, I think it's 20. My course, entire thing exploded there for a second. Hang on, here we go. Go back, make sure. All right, 10 minutes. And what have we got? 2.5, so 2.5 hours. 2.5 hours. All right. Yeah, and then Thursday we'll pick up 1-3. That's the plan. I don't have blank notes for that. I'll have those out to you tomorrow. And since I'm I think using Notebook is the way to go, I may just share this file with you as the Notebook file. But we'll get through the tests and get through the notes before we worry about such small things as what we're going to do with the next file type. All right, so we've gotten through the first 4 pages. We have 3 left. So I know Tinny, you said you had a question. If you don't mind, let me finish and make sure we don't answer your question in the rest of the lecture. And then when I get done, then we'll just do questions from R.8, questions from the test review, any of the things you want to. All right. All right, so back in, we are diving right back into solving absolute value inequalities. There are the 3 steps, okay? The cardinal rules of absolute value. Number 1, isolate the absolute value. 2, separate the absolute value. It's either going to be a greater, which is an or, so that means you're either going to have what's in the absolute value is exactly what it says, or it's the opposite direction for the inequality and the sign of the other side goes negative. If you, then the other case is you have the absolute value is less than. That's the and situation where what's inside the absolute value is it has to be both less than exactly what's in the absolute value, and greater than the opposite. Okay, so let's tackle these and see what we come up with. So I'm solving for 5 times absolute value of 2c plus 7 plus 1 greater than or equal to 11. And then let's since we're at the beginning of class and we're getting our minds warmed up here, let's just remember exactly what's going on. I'm asked to solve this inequality. It's an inequality because there's not an equal sign in there, there's a greater than or equal to. So I'm asked to solve, which means I need to get c by itself. C is currently inside an absolute value. The only way to get c out of the absolute value is to isolate the absolute value, because that's the only way I'm allowed to take the bars off. Right? I can't multiply or divide by both sides. I can't do anything to what's inside those bars until I have just the absolute value is some inequality to some other side, something on the other side. So in this case, I'll end up with the absolute value is greater than or equal to some number. So I need the absolute value by itself. It's currently being multiplied by 5 and then having 1 added to it. So I'm going to get rid of the 1 first. And the reason is if I tried to divide by 5 first, I would have to divide this 1 by 5, which means I would have the absolute value 2c plus 7 plus 1/5, and then subtract the 1/5. We don't like fractions, or students don't typically like fractions. So that's why we get rid of the 1 first. Right? Everything with the absolute value on one side, everything without on the other. 11 minus 1 is 10. And then I told you you can't do anything, you can't do any math of what's inside the absolute value, but you can divide something on the outside. The 5s divide away, leaving 1s, and then the 10 and the 5 reduce to 2. So I've got the absolute value of 2c plus 7 is greater than or equal to -2. That is a greater, right? And when I have a greater, it means I got 2 things going on. Either the absolute value is exactly what it says. You just rewrite what's inside the absolute value. You leave the inequality alone. You leave the right-hand side alone. Or it's the exact opposite, which is what's inside the absolute value stays exactly the same. The inequality changes directions, and the sign of the other side changes directions. Solve both of these individually. -7 means, looking at it, 2c is greater than or equal to -5. And then get c by itself, divide by 2, divide by 2. C is greater than or equal to -5/2. Or, okay, the 2 steps to get c by itself are exactly the same. Notice that it subtracts 7 on both sides. And then my answer is different on the right because I started out with a -2. And then I'm dividing by 2. Does everybody understand what I mean there? I said the steps are the same. In both sides, I subtract 7 from both sides. I divide by 2. The process of getting there is the same. All right, so here I am. C is greater than or equal to -5/2, or C is less than or equal to -9/2. Let's take a look at this on the number line. In order to do it, we're going to have to think about fractional negative numbers, which can be very difficult. All right, so just not for notation's sake, but just as a little aside, -5/2 is -2.5, right? That's 2 goes into 5 twice with a 1 left over, so that's 2.5, which is 2.5. -9 halves is what? 2 goes into 9 4 times with the 1 left over. So we get negative 4.5. Let me do that to the other side too to clear it, just in case. There's nothing worse than trying to look at these notes after class and you can't figure out what in the world I meant. Okay. Why did I bother to do that? Because it's a whole lot easier to put negative 2.5 and negative 4.5 on the number line than it is to put negative 5 halves and negative 9 halves. So they are where? Negative 4 over 5. If I'm starting on the left and I'm working my way to the right, the first number I'm going to hit is the negative 4.5. And then the other one is negative 2.5. Now the question is where do these go? Which direction are we going in? C is greater than or equal to negative 5 halves. That's the negative 2.5. That's going to correspond to everything to the right of negative 2.5. And does it include the negative 2.5 or does it not include it? Yes or no? Yes. Yes, it does. All right, so it is included, which means this gets a bracket. And then to go on to the other side, C is less than or equal to negative 9 halves. Negative 9 halves is the negative 4.5. So I'm looking at all the things less than that. So that goes all the way to forever. And just like the other, this is included. They're always going to be the same unless you get a problem set up where it's an and they've told you the sign, one's greater than or equal to, one's strictly less than, or one's strictly greater than, one's greater than or equal to. When you're solving these absolute values, it's always going to be, if one side has the endpoint included, the other side is going to as well. Okay. So I've got what? Well, I have all the numbers less than negative 4.5. Well, that's negative infinity to negative 4.5. And then I have the negative 2.5 off to positive infinity. So that means my answer is what? Well, negative infinity. Infinities always get a parenthesis because you can never capture infinity, right? Up to negative 4.5, it's included, which is why the bracket pops in. And we have the negative 2.5 off to positive infinity. Infinities are never included. Negative 2.5 is included, so it gets a bracket. And then to join two things in that notation, I need that union symbol. So that's where the U comes from. And there's our answer. All right, what does this mean? This means that all of the numbers less than or equal to negative 4.5 or greater than or equal to negative 2.5 all satisfy the equation above and make it a true statement. All right. Okay. Not too terrible. I know it gets weird because now instead of just having one answer, now I've got an infinite set of answers, which means I have to write them as a set, and I can't just write x equals 4 and then do the brackets and then just list all the answers in it, right? Because I can't list all of these numbers. So remember, that's why we're using this interval notation. The book talks about set builder notation, and I'm just going to show you what that would look like. So it starts out with a bracket, and you get C. You get a big straight line. It looks like half of the absolute value. It's just a straight line, straight vertical line, and it reads as such that. And then what you do is you put in the inequalities that you found. C is greater than or equal to negative 5 over 2, or C is less than or equal to negative 9 over 2, and you close parentheses. or excuse me, you close the curly brace, curly bracket. Okay, so this is called Sept builder notation. And then this is called interval notation. I think everyone would agree Sept builder notation looks easier because we don't have to convert over to interval notation. You're right, it probably is. Which one should you use? You should use the one that the book, that Alex is asking you to use to get the right answer. And typically when you bring in a computer to try to tell if the answers are right or wrong, the interval notation is typically the way it's going to go, because it's really easy for the computer to determine, did you write that correctly, versus, you could swap the order of the C's and you got an or in there to get that Sept builder notation in there. All right, so isolate, separate, I isolated, I separated, and then liberated by getting the C's out now by themselves. So let's take a stab at this one. Okay, well now they've gone and done something else, right? Now they've added some rational expressions to this. Now I have the absolute value of 3w minus 2, all divided by 2, plus 6 is less than 8. Okay, again, you don't know how to do this problem yet, but you can make it look like a problem you know how to do very easily. Anytime we've got these fractions and we have two sides, we have an equation or an inequality, the best thing to do is get rid of those fractions or clear them if you're allowed to. Are we allowed to? Yeah, I can multiply both sides by 2, right? The LCD of this whole inequality, all three terms here, is 2, because 2 is the only denominator we have. The 6 is over a 1 and the 8's over a 1. So if I multiply both sides by 2, what does that do for me? Well, it takes away the denominator from the absolute value term. And now 6 times 2 is 12, 8 times 2 is 16. And now this is a problem you can do, right? Now this is a problem that you absolutely know how to do. So let's subtract 12 from both sides. So you see how one technique from a while back and then one new technique come together to get you what you need. So what am I looking at? This is the less than, right? So if it's a less than, it means whatever's inside the absolute value is bounded or trapped between whatever it's less than and greater than the opposite sign of the right-hand side. So if your absolute value is less than, that means my numbers are trapped between 4 and -4, right? Because do you remember the idea of if the absolute value, some absolute value is less than 4, that means the answer is all the numbers that are less than 4 units away from 0, right? That's why it gets trapped on both sides. Absolute value is gone. The absolute value is gone, but W is not by itself. So again, we feel the need to get W by itself, or we have that need, and the process is the same as before, 3W minus 2. Everything with the W needs to be by itself. Everything without a W needs to go away. If I add 2 to the middle, I've got to add 2 to the left and the right. And then the last step, get W by itself. It's currently multiplied by 3, which means dividing by 3 will get rid of it. I divided, but I didn't divide by a negative. So my Inequalities do not change directions. And here's what I end up with. Negative 2/3 is less than W, which is less than 2. All right. Want to write that in interval notation. I'm starting at 2/3. I'm going up to 2, and then I take my step back. Is negative 2/3 included? No, because this is a strictly this is a strictly greater than, or excuse me, less than. So since it's strictly less than, it's parentheses. Strictly less than on the right, it's parentheses. Don't worry if you're not sure which one's a less than, which one's a greater than, if you don't know how to read it. It just takes time and you still forget it sometimes. Yeah, just don't let that bother you. As long as you can get our answer, figure out our absolute value, get it to the less than situation or the greater situation. And remember, the parentheses indicate the endpoints are not included in the solution set. So that means negative 2/3 is not allowed and 2 is not allowed, but everything between those two is allowed. Okay? Any questions? Okay. Y'all are like eerily quiet today. Okay. So if there are no questions, let's tackle this last question. And I do want you to just take a note. The number has changed in yours. In your problem, it says on the right-hand side, you have less than or equal to something. I can't read it anymore. Less than or equal to some number. I have swapped that number out for negative 20. I think it's negative 2, but I don't know. So on the right-hand side, instead of whatever you had, replace that with negative 20. Okay? And the reason for that is if you don't, the solution comes out and it just makes a big old mess. All right, so this is looks complicated, looks nasty because fractions have appeared. Now they're inside the absolute value and there's work to be done. Don't let hard work scare you. It is not that bad. I want to isolate the absolute value. So everything with an absolute value goes to one side, everything without goes to the other. That means that negative 14 needs to go away. And I get rid of that by adding it to both sides, which means I now have negative 2 times the absolute value of 3/2 x plus 6 is less than or equal to. Negative 20 plus 14 is negative 6. And now I have to do I deal with the devil here, divide both sides by a negative. And it's fine for you to do that, but remember it's going to impact your absolute value, right? So that means, or excuse me, not an absolute value, it's going to impact my inequality. My sides are still, on the left-hand side, the absolute value is now by itself. On the right-hand side, negative 6 divided by negative 2 leaves me a positive 3, but my inequality was less than or equal to, and now it's greater than or equal to. All right, and we wouldn't typically write that plus. Okay, so questions. Everybody good with that? So we made our little, there's our hiccup for these. And what have I got? I have a great TOR situation, which means this splits into 2. Either 3/2 x plus 6 is greater than or equal to 3, or 3/2 x plus 6 is less than or equal to negative 3. If two numbers are left, the absolute value bracket. Oh, so that negative, when that minus 2 is over there, that means that 2 is multiplied. So that is that 2 is multiplied by, it multiplies everything inside the absolute value. Trouble is I can't distribute it because I'm not allowed to do math inside the absolute value. So that's why I have to get rid of it with the division. The negative 14, so that's negative 14 minus the term with the absolute value in it. So that negative 14 over there, it could, you could rewrite the problem or write the problem as x plus 6, and see this is minus 14 or plus negative 14. It's just there's a negative 14 on that side. Okay? And to get our answer, what we need to do is take negative 14 and then subtract 2 times the absolute value. So it's just sitting over there. It's sitting over there in the same way that if I wrote negative 14 minus 2x is less than or equal to negative 20, solve for x, it's the same idea. That 14's over here. Everything with the absolute value stays. Everything else goes. That's why I add 14 to both sides. Right? If it helps algebraically, you can always let's see, problem with something like this. Should I assume that add or subtract? Yes, absolutely. Yes, you should assume that. And the reason I know so you can't read the notes. Like I can't see a problem with something like that. Should I assume something in that place is added or subtracted instead of multiplied? Yes, you should. And the reason is because this minus 3 times x plus 6. So the terms are separated. So negative 14 is a term, and then the 2 times the absolute value is a term. Terms are separated by pluses and minuses. So yeah, if it's separated by a plus or a minus, it is added or subtracted, which means adding or subtracting is the way to get rid of it. If there is no operator between them, such as the 2 and then the absolute value, if there's nothing between them, that implies multiplication, which means to get rid of that, I've got to do division. Okay, good questions. And the same thing if the negative 14, if it was minus 14 and it came after the absolute value, but it was still on the left-hand side of the inequality, same idea. It's subtract 14, or I need to get rid of that subtract 14, so I add 14 to both sides. Okay. So I've got my 2 inequalities, and I'm going to do the same thing as I did before. And I'm going to just do it to both of them. That fraction in there is going to cause problems if we don't do something about it, because multiplying or adding and subtracting fractions is where everybody's head just gets messed up. So 2 times 3 halves is 3x, plus 6 times 2 is 12, greater than or equal to 6. Everything with an x to one side, everything without to the other. And now I'm looking at 3x greater than or equal to 6 minus 12 is negative 6. And then divide both sides by 3, and x is greater than or equal to negative 2. That's one of them. Now we'll go the other direction. Same thing, I'm clearing the fractions. Distribute that 2, and I'm looking at 3x plus 6 is less than or equal to negative 6. No. I didn't distribute, did I? Distribute. 6 times 2 is 12, Larry. Some alarming news. 6 times 2 is 12. Everything with an x to one side, everything without to the other. 3x is less than or equal to negative 18. I want the x by itself. That means I got to divide both sides by negative 3 or by positive 3. Again, I divided, but I did not divide by a negative, so the inequality stays the same. Less than or equal to negative 6. The number line again is helpful. Notice there's not a fraction now, so I don't really have to rewrite these numbers to help. Here's negative 6, here's negative 2. I know my answer contains everything less than negative 6 up to and including negative 6, and everything greater than negative 2 starting at negative 2 and including it. That means my solution set looks like what? Start at negative infinity, go up to negative 6 and include it. Then skip over all the numbers between negative 6 and negative 2, pick up at negative 2 and go to positive infinity, put them together with that union. Now, the note at the top says example of interval testing. So what I want you to do, or what I want you to notice about this is we're saying not just that negative 6 works, everything less than negative 6 works. We're saying that if the number's between negative 6 and negative 2, it's not a solution. And if I have a number greater than negative 2, it is a solution. So we can do a check of our intervals to see if we're right. So this left-hand side, I'm going to pick a number in there. I'm going to pick negative 10. And based on our answer, negative 10 is in the solution set. So that means what? If I plug negative 10 in for x, 3/2 times negative 10 plus 6 less than or equal to negative 20. If I plug that in and then work the problem, when I get to the end, I should get something back that is true. Do I? Let's find out. Negative 14 minus 2, negative 3/2 times negative 10 is negative 15. Negative 15 plus 6 is negative 9. And now I can take the absolute value. All the math inside is done. So I can take the absolute value of negative 9. And that is what? 9. Two times 9 is 18. This is minus 2 times 9, which means it's minus 18. Negative 14 minus 18 more gives me negative 32, which is less than or equal to negative 20. That is true. So that means that interval checks. Everybody understand the idea here? If you plug in negative 1 million to this, it will come back true. Because not only is negative 6 to the solution set, everything smaller than negative 6 is in there. Same thing goes for the right-hand side. Everything greater than negative 2 is in there. So if you want to check that one, I would argue, whenever you get a chance, check 0. Because 0 usually makes the problem a whole lot easier, because it makes at least whatever, all the terms that have x in them go away. 3/2 times 0 plus 6 less than or equal to negative 20. I plugged in 0, so that means I'm looking at the absolute value of 6. Absolute value of 6 is 6. Careful not to do any math with the 6 until the absolute value has been removed. So it's negative 14. 2 times 6 is 12, so that's negative 14 minus 12 more. Negative 14 minus 12 is negative 26. Negative 26 is less than or equal to negative 20. That is true. All right. So both of those do work. Both of those check. That's exactly what we expect. Now let's find one that doesn't. So numbers between negative 6 and negative 2. I'm going to go with negative 4. And the reason I'm going to do negative 4 is take a look on the inside of the absolute value. See that 3 halves in there? That's going to then times x. If I put something that is a multiple of 2 in there for x, that fraction will go away. And if the fraction goes away, it just makes the whole problem a lot easier to work. So we're going to check negative 4, and then we'll take questions for the test. So check negative 4. If I did the math right, if my answer is correct, then this should return something false. All right. So negative 14 minus 2 times absolute value of 3 halves times negative 4 is 3 times negative 2, which is negative 6. Negative 6 plus 6 is 0. How far away is 0 from 0? It's 0 units. Notice that I took the absolute value of 0 and got 0, and then I do math with it. 2 minus 0 is 0. Negative 14 is less than or equal to negative 20. That is false. So that means that exactly what we thought happened. Okay. The other time interval testing is useful is if you have a complicated problem, if you can figure out all the times where your inequality goes positive to negative, you can just test those intervals. But I'm not going to push that topic. I'm not going to push that way of doing it. I like the way we're doing it here, so I want you to stick with this. But this is the idea, and this is interval testing as well. Okay, it's useful for inequalities because I have entire sets of numbers. Interval testing is not useful for solving equations because equations usually have 1 or 2, some finite number of solutions, 1 or 2 or 3 solutions. All right. Any questions? That's the end of R8. All right. If there aren't any, how about you tell me the questions? I know there were questions. I was told there were questions from Alex. Let's go in here. There's number 5 from R8. Perfect assignments. Here's R8. And I'm looking for number 5. And what I'm going to do is I'm going to paste the answer, paste the question over so everybody can see it. Solve the compound inequality. 3u plus 6 is less than 3, or 4u minus 5 is greater than negative 21. Write the solution. So we're going to tackle them both. This is an or, so I got to get after both of them here. 3u plus 6 less than 3. Everything with the u to one side, everything without to the other. That's 3u less than. 3 minus 6 -3. I get u totally by itself, so divide both sides by 3, and that means u is less than -1. My other side says 4u minus 5 is greater than -21. Everything with the u is already on the left, so everything without needs to go to the right. Add 5 to both sides, and I'm looking at 4u greater than -21 plus 5 is -16. I want u to be totally by itself. Divide both sides by 4, and I find that u is greater than -4. So, what do we have? I really like doing the number line when I get one of these because of the special case of what's happened in this problem. And because it just helps you with your ideas here. So I'm going to do the less than -1 in red and the greater than -4 in blue. Where these are the two numbers that I'm going to encounter. There's -4, there's -1. And for -1, I don't include -1, so that gets the parenthesis, but I do include everything to the left of it. All right? And then for the greater than -4, I don't include the -4, so that gets a parenthesis, but I do include everything to the right of it. All right? Now, here's something we haven't seen before. These intervals, this is an or, and the intervals overlap. Remember, the rule says when I have an or, it only has to satisfy one of the two. Typically, overlaps are things we see with an and situation, but this one's an or. So anywhere on that number line that has the color red or the color blue or both is a solution. That's every single number up there, right? So since that's every number up there, that solution or the solution set is everything. And everything is start at -infinity, go to +infinity. Okay? The other funky one that you can get is a case where you have an and, but the two intervals don't overlap at all. When that happens, that is when this comes into play. That's the empty set. I mentioned it in passing, I think right there at the end of class last time. So you can, click that and put that in as your answer. And then let me show you, I don't know if the shorthand works. No, it doesn't. So now you have to click -infinity, infinity. Oh, don't put -infinity twice because that's wrong. To infinity. Okay. And yet the notation, this one doesn't make you put the u as an element of, and because it just says give me the interval. All right. And you should take a look at if you take a look at this and you think, do I need to put u as an element of? There is no is an element of symbol. So that means I can't type it, which means it's not part of the answer. All right. What else? What other questions do we have? Any questions from the review? Question 5. Okay, question 8. All right, and we're looking at the review now. Let's take a look at question 8 in the same section. Question 8. Question 8 says, graph the solution on the number line. All right. I got a feeling this is more of a data entry problem than a mathematical one. So I have right in there, this is one of those less than, right? So that means whatever's inside the absolute value is either less than 9, which is exactly what it says. It also has to satisfy, I don't know why I put an equals there. It also has to satisfy the fact of being greater than negative 9. Okay, so I'm going to solve this for W, which means get W by itself. Negative 9 minus 12 more is negative 21. And then 9 minus 12 is negative 3. And now we make our deal with the negative gods. I can divide both sides by negative 3, but in the process, I have to flip my directions. So my less thans become greater thans, which means the problem looks weird, right? So let's read it. Let's see, what does this mean? This means W is less than 7 and greater than 1. Whenever the inequalities get flipped like this, it's always helpful to flip everything back in the way you're used to. So what we're used to seeing is when we have an and situation and we get the solution, it means that have a number less than or equal to the variable less than or equal to some number. So if I wanted to switch the directions without changing anything mathematically, I'm going to start at 1 and then W and then 7. And I'm just going to write the inequalities, but I'm going to match up everything. So if this is W is greater than 1, right? Well, W is greater than 1. That's W is greater than 1. It's also 1 is less than W. They're the same thing. Okay, and then 7 is greater than W. 7 is greater than W. All I did was make sure that my inequalities kept the relative side toward the same thing. In this greater than, the 7 is the symbol is open toward the 7 is closed toward the W. Open towards the 7, closed towards the W. In this one, the W, it's open towards the W, it's closed towards the 1. Open towards the W, closed towards the 1. So what's that going to look like on my graph? From 1 to 7 is covered, and instead of brackets and parentheses, they're going to use, when you're plotting this on a number line, they're probably going to use open and closed circles. So let's see if that's the case. And so, yeah, all right. So 1, okay, so if I just click interval, it just does everything. Yes, I will. So what I need to do is pick my endpoints. So there's 1, there's 7, and then the interval means it's either select all the numbers less than 1, all the numbers between 1 and 7, and all the numbers greater than 7. So the only answer I said was the numbers between 1 and 7, not including 1 and 7. So you set your points or set your endpoints. If they're parentheses, open circle. If they're brackets, closed circle. And then highlight the intervals or intervals that are in the solution. All right, so there's our 8 question. Now let's take a look at the review. Where am I? The test review, and take a look at 8. All right, let's get a new page up on chapter R, review question 8. Let's make it large. Solve for U. If there's more than one solution, separate them with commas. If there's no solution, click no solution. All right. So I have a rational equation, right? I've got numerators and denominators, my variables in the denominator. So this is what makes it rational. It's an equation because it has an equal sign and it's got things on both sides of it. So I have a rational equation. Whenever I'm dealing with rational equations, I'd like to get rid of the fractions, right? So what do I want to do to get rid of the fractions, or what can I do? I need to multiply both sides by the least common denominator. Remember, that's the smallest term that all of the factors and all of the denominators go into. All right. My chair is creaky today. Okay, you got the answer, but you couldn't end it. Okay, let's see. What is my LCD? Well, the 4, that's 4 over 1, so it's just got a 1. The 3 over u plus 3 has a factor of u plus 3 in it. The 3 over u plus 2 has a factor of u plus 2 in it. So to find the LCD, if the factor appears multiple times, it only gets counted once. If it happens one time, you put it in there once and then you multiply. Whenever you do these, leave it in its factored form until you do that step, until you distribute or multiply both sides by the LCD. I'm just gonna multiply by the LCD. So what does that leave me with? 4 times the LCD is 4 times u plus 3 times u plus 2 plus 3 u plus 3 times u plus 2 over u plus 3. The u plus 3's go away, leaving me u plus 2 equals, on the right-hand side, the u plus 2's divide away, leaving me a u plus 3. Can everybody get that step without looking at the rest of the work? Is everybody comfortable with what just happened there? I multiplied both sides by u plus 3 times u plus 2. And then this is what ends up. All right, so multiply. That's u squared plus 5u plus 6 plus 3u plus 6 is equal to 3u plus 9. This is going to be a quadratic. Distribute that 4u squared plus 20u plus 24 plus 3u plus 6 is equal to 3u plus 9. Combine like terms. On the left-hand side, there are like terms. 4u squared, 20u plus 3u is 23u. 24 plus 6 is 30. This is a quadratic. So to solve a quadratic, we get everything on one side and 0 on the other. So to do that, I need to subtract 3u, and I need to subtract 9. Which means I am now looking at 4u squared plus 20u plus 21 equals 0. And then Does this factor, well, that leading coefficient of 4 is frustrating, right? Since leading coefficient is a 4, that means factoring this, just breaking this into two binomials immediately is going to be really difficult. So I'm going to come over here to the side and do my little bottoms up. You could also use, and this may not work, bottoms up, also called the AC method. I multiply A and C, which means I end up with 4 times 21, which is 84. Oh, B is higher. How so? Oh, you had a different problem. I see. All right. Does anything work for this? The right hand too. Does anything multiply to 84 and add to 20? 8 and 4 is 12, so it's divisible by 6. Yeah, 16 and 4, exactly. So this will factor into u plus 16, u plus 4. But then remember, you have to come back and deal with the fact that you multiplied both sides by a. Let me just, again, this is for us and for the people that come behind us. A times C is what gave us the 84, and now this 4 is what's dividing. So I end up with, oh, both of those divide. U plus 4 times U plus 1. Well, that can't be right, can it? And if I multiply that back out, it doesn't work. 16 times 4. 16 times 4 is 64, not 84. Okay. I thought it too there for a second. And I was like, oh, this is going to work out perfect. Let's see. I know 6 goes into this 84. Divide 6. It's 14. That's it. We were almost there. 14 and 6. Now do that division. Now we're going to get something that looks looks more right. I don't know how else to say that. Do these reduce? Yeah, 14 divided by 4. The 14 and the 4 both have a 2 in them, so we factor it out. Or we divide out the 2, we get 7 over 2. Same thing, 6 and 4 have a 2, so that leaves me a 3 over 2. And then I can always write these. You can write them as take the denominators, put them out front. If you want them to look like, this is the old, if you want it to look like you baked all day in the kitchen, you just throw a bunch of flour on your face, put in something that was pre-made, and you're like, oh yeah, look, I factored that. It's just such a hard work. What's going to happen though? I got two things that multiply to give me 0 by the zero product principle. Either the first one is 0 or the second one is 0. Solve for u. Subtract 7. Divide by 2. And if we didn't pretty these up, you already knew u is equal to negative 7 over 2. Because it's right there. Right? U plus 7 halves equals 0, so u is negative 7 over 2. Same thing here, subtract 3 from both sides. 2u is equal to negative 3, divide both sides by 2. and u is equal to -3/2. So those are my two solutions. Do they work? Right? I got to check. So original problem 4 plus, actually steal it from here. So original problem and paste in. And then we're going to check. So I check -7/2, and I check -3/2. Now, this is going to be the first time you ever see me do this. And it's because what I'm dividing by, if I make these decimals, they don't, they're not infinite repeating. They actually they're called terminating decimals. 7 divided by 2, 7/2, that's 3.5. So it's -3.5. 3/2 is 1.5, and that's negative, so that's -1.5. So instead of plugging in fractions, because my variables are in the denominator, which just make life super fun, I'm going to let you deal with these in terms of decimals, because I expect any of this checking to be done on a calculator and not by hand. 3.5 plus 2. If you had like 7/3, you can't do this. Because you have 7/3, base 10 doesn't do well when you divide by 3, 9, and 7, right? The variable, the decimals go on forever and ever, so it makes life more difficult. So I'm looking at 4 plus 3 over -3.5 plus 3 is -0.5 equal to -3.5 plus 2 is -1.5. And then if I put these in a calculator, I'm going to find out that 3 divided by -1/2 or -0.5 is -6. And then on the right, 3 divided by 1.5 is what? 2. And it's positive divided by negative, which is negative. 4 minus 6 is -2, which means -2 is -2. That's true. So this is one of this is a solution. Now let's check the other. 4 plus 3 over -1.5 plus 3 is equal to 3 over -1.5 plus 2. 3 over -1.5 plus 3 is 1.5. And then -1.5 plus 2 is -0.5. 4 plus 2 is equal to -6. And I get 6 is equal to -6. That's not true. So that means -3/2 is not a solution unless I've made a mistake along the way, which I don't think I have. So that means -1.5 is not a solution, but -3.5 is. So the solution set should contain -7/2. And let's check my work. What's the point? We don't make sure we're right. Oh, you found some, but not all. So let's see if it's in there. I get -7/2, 3, 2. It's saying, oh, no. Oh, right there. Look at me being a silly, silly goose right there. Negative 1.5 plus 2 is not negative 1 point. It's not negative 1/2, it's positive 1/2. Which makes all the difference because now this is positive, which means this is positive, which means 6 is 6. So that does check. So that means my solutions are negative 7/2, negative 3/2. For problems like this, if you're going to run into an extraneous solution, it's probably going to be, you can look at the very beginning, numbers. There are two numbers that if I plug in for you, they immediately cause division by 0. Those numbers are negative 3 and negative 2. So if I plug those in, they're going to immediately cause division by 0. They cannot be solutions. So if you're going to find extraneous solutions, that's typically what they're going to look like for rational equations. All right, so that's it. We're out of time. If you run into a problem on the review and you want some help with it, then send me, you get a little button right here. Right here it says message center. You can send me the exact question that you're looking at. I'll get it in my email. I will check it. I'll either type it out and write it to you, or I'll sit down with a laptop and something and then try to explain it and send it back. All right, y'all have a good day.